Okay, so we left off last hour talking about the greatest common factor factoring. And let's do one more example just to see how you're doing with them. Let's do 45x to the third y plus 60 x squared y to the fourth minus 30 x y to the fifth. So find the greatest common factor and divide it out to factor that. So for the number, what's the greatest common factor numerically? 15. Variables? X, Y. That's it. So we're going to divide this out by 15xy, and we get 3x squared. 45 divided by 15 is 3. X to the third divided by x is x squared, and the y's divide out. And then positive 4x y to the third, good. 60 divided by 5 is positive 4. X squared divided by x is x. And y to the fourth divided by y is y to the third. And then negative 2y to the fourth. Good. Negative 30 divided by 15 is negative 2. X divided by x divides out. And y to the fifth divided by y is y to the fourth. How many of you had that? Anybody have any questions on where that came from? Okay. Well, that is the greatest common factor method of factoring. And when you're asked to factor, the first thing we will always look for is a GCF, greatest common factor. If there is no greatest common factor, or if we've already found a greatest common factor, well, then there are other things we can look for. You know, we saw that this greatest common factor is reversing this multiplication, which was distributing. But we've had other multiplications that we looked at last class that look something like this. And we multiplied that out. We did x times x was x squared. X times 7 is 7x. 3 times x is 3x. And 3 times 7 is 21. We added those up to get x squared plus 10x plus 21. We did it out using the long multiplication last time. I used the FOIL shortcut here this time. Is there anybody that wants to see me multiply it out the long way? Okay. So anyway, if we are asked to factor something like that, we look at it, is there a greatest common factor there anywhere? No, there is no greatest common factor there. So the next step, and it only works if it has 3 digits, 3 terms, is to try to do reverse multiplication. Sometimes referred to as FOIL in reverse. I don't necessarily like FOIL, so I don't really call it FOIL in reverse, but it kind of is that. And what it is that we take this solution we got for this multiplication here, and we see that the x squared comes from multiplying those two numbers, x times x. And we see that the 21 comes from multiplying those two numbers, the 3 times 7. The middle digit, the 10x, is a combination of these two results, which comes from multiplying the outside, the x times 7 is 7x, and the inside, 3 times x is 3x, and then combining those to make the 10x. So if we wanted to split this up, we would use that pattern. We would look at this and say, hey, the x squared had to come from x times x, from the first 2 digits. The 21 can either be 1 times 21 or 3 times 7. So we pick one of those, and we're going to do 1, or not 1, we're going to use 3 times 7, of course, because we know the answer because we just multiplied it. And we double check to see if that is the one we want. We double check on the outside. What is x times 7? 7x. On the inside, 3 times x is 3x. That adds up to 10x, and that is what we want. So x squared plus 10x plus 21 factors into x plus 3 times x plus 7. So when I look at this, first question, are there any common factors? Say no. No, there's not. Good. So the next step, since it's 3 digits or 3 terms, is to try to do reverse multiplication. And it's going to be two two-digit numbers or 2 binomials. The first 2 digits have to multiply to make what? X squared. So probably x times x, right? The last 2 digits have to multiply to make 20. So we have choices. 2 times 10, 1 times 20, or 4 times 5. 4 times 5? Now it's a positive 20, so it's most likely a positive 4 and a positive 5, or it could be negative 4 times negative 5. Just to know. How do we know if it's 4 and 5? Well, we double check. On the outside, what's x times 5? 5x. On the inside, 4 times x is 4x. That adds up to 9x. Is that what we want? Yes, it is. So x squared plus 9x plus 20 factors into x plus 4 times x plus 5. So we go to factor this. Any greatest common factor. Any common factors, period. No. No, there's not. No common factors. Right? Because this is a 1 here. So there's no numbers, and then there's no x in this one, so there's no variables. So there's no common factor. So we're going to try to do this reverse multiplication again. X times x to make x squared. Now 8, we either have 1 times 8 or 2 times 4. Let's try 2 times 4. So on the outside, x times 4 is 4x. On the inside, 2 times x is 2x. Adds up to 6x. Is that what we want? No, it is not. So we're going to try something else. We've got x and x. And let's do the plus 1 and plus 8. So now on the outside, x times 8 is 8x. 1 times x, 1x. That combines to make 9x. Is that what we want? Yes, it is. Perfect. So x squared plus 9x plus 8 is equal to x plus 1 times x plus 8. Split it up, factor it out, and try all the possibilities. Yep. Yes. So here, common factors. No. So we're splitting it up into two two-digit numbers, or 2 binomials. X times x would still make x squared. 24 can be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Which one do we want to use? The first one. Positive 1 and positive 24. Some of you are starting to see that they multiply to make this, but then they add to make that, right? So let's test just to see. X times 24 makes 24x. 1 times x, 1x. Adds up to 25x, which is what we want. So x squared plus 25x plus 24 is equal to x plus 1 times x plus 24. So try this one. Try that in your notes. So again, no common factor. So we're going to split this up. X and x makes x squared. 48, of course. 1 times 48, 2 times 24, 3 times 16, 4 times 12, or 6 times 8. Which one do we want? 3 times 16. Very good. We double check. X times 16 is 16x. 3 times x is 3x. Adds up to 19x. So yes, that's the one we want. Well, because it's me, let's muddy the waters a bit. Let's see here. Common factors. No. Because this is a 1, so there's no number, and there's no x here, so no common factors. No common factors at all. The common factors has to go to every digit. So that,
never common factors on the
well, there might be. Give me time. We'll get to it. If this is a 1 here, or there's no number there, then there's no numerical common factor. If there's no variable in any of them, then there's no variable. There's a common factor. And it has to go into all of them, not just 2 out of the 3. So we're going to do this. Of course, x squared will be x times x. 12 would be 1 times 12, 2 times 6, 3 times 4. Which one do we want? Sort of 2 times 6. There we go. Negative 2 times negative 6. Remember, a negative times a negative is still positive. Here, this is a negative 8. So negative 2 times negative 6 is a positive 12. We have negative 6x, negative 2x makes negative 8x. So let's take x squared minus 34x plus 64. Try that one in your notes. So no common factors. X times x makes x squared. How about the 64? Well, this is negative, so we know this is going to be negative and a negative most likely. 1 times 64, 2 times 32, 4 times 16, 2 times 32. Negative 2 times negative 32. Perfect. I'll leave it up to you guys to double check it. Well, this one, common factors. No. What's different about this one, though? It's a negative 15 here. This is the issue. It's negative here. To multiply to make a negative number, we're going to have to use 1 positive and 1 negative. So, x times x still makes x squared. 15 is 1 times 15 or 3 times 5. But again, one of them's positive and one's negative. So let's do positive 3 and negative 5. X times negative 5 is negative 5x. 3 times x, positive 3x. That combines to give us negative 2x. At first, that looks almost like it's what we want, but it's not quite. We want a positive 2x. What that's telling us, though, is we got the right number, just the wrong sign. It's negative instead of positive, or the other way around, positive instead of negative. That just means we've got to change the signs. This is going to be a negative 3, and this will be a positive 5. Now, if we double check, x times 5 is 5x. Negative 3 times x is negative 3x. That is 2x. So that's what we want. It's x minus 3 times x plus 5. Try that one in your notes. Again, no common factor. So x and x. 21, of course, is going to be 1 and 21, or 3 and 7. I tried to make it somewhat easy on you. Which one are we going to use? 3 and 7. Which one's going to be positive? Positive 3, negative 7. So when we check, x and negative 7 make negative 7x. 3 times x, positive 3x, adds up to negative 4x, which is what we want. So x squared minus 4x minus 21 is equal to x plus 3 times x minus 7. Try this one in your notes. What's the first thing we always look for? Common factor. Which will be 5. Divide by 5, that is x squared minus 2x minus 3. However, just because we found a common factor does not mean we're done. We still have to check to see if we can split this up anymore. And we can. The 5 is going to stay. Or the 5 isn't going to change. But we can split that up into 2 pieces yet. X times x makes x squared. And of course, 3 is going to be negative 1 times 3, or negative 3 times 1. We're going to do the negative 3 and the positive 1 times negative 3. And we're going to check. X times negative 3 is negative 3x. 1 times x is positive 1x. That does give us negative 2x. So 5x squared minus 10x minus 15 factors into 5 times x plus 1 times x minus 3. How about this one? It's the first thing we always look for. Common factor of x squared. You got it. Which leaves us with x squared plus 7x plus 5. Are we done? No. The x squared isn't going to change, but we can split this one up. X times x, of course, makes the x squared. 5 is going to be, oops, I screwed up. I don't know where that 5 came from. That should be a 10, shouldn't it? 10 splits up into, I don't know why the 5, where I put the 5 in there.
I was like, what the heck? I'm like, well, how the heck did it get
5 out of 10.
I have no idea where the 5 came from. That's 10. So 10 splits up into 2 and 5. And now we can double check. X times 5 is 5x. 2 times x is 2x. Adds up to 7x, which is what we want. So x to the 4th plus 7x to the 3rd plus 10x squared factors into x squared plus, or x squared times x plus 2 times x plus 5. What do you think? Better than a sharp stick in the eye? Absolutely. Good. You'd rather do this than word problems? Well, that's, I guess, one way to put a positive spin on it.
So don't even think I'm not near word.
How can I put one of these into a word problem? Sorry. In engineering, you actually can do it, but we're not gonna go there. I'd have to
Not going that
I'd have to go into either a reflection problem or a beam bending problem, and we don't want to go there. So anyway, oh come on, now that's not a very happy attitude. What's different here? Well, there's a 2 on the x, right? On the x squared. In the past, we've had that happen, but we were always able to factor it out with a greatest common factor. Do we have a greatest common factor here? No, we do not. That complicates things a lot, actually. 2x squared now has to factor into 2x times x. Two x times x makes 2x squared. Now the 15 is either going to be 1 times 15 or 3 times 5. Let's try the 3 times 5. So 2x times 5 is 10x. 3 times x is 3x. That adds to make 13x. That's not what we want. Does that mean 3 and 5 are the wrong ones? We want to go with 1 and 15? No, it doesn't. Because it's not, before it was always x and x, so the order for these didn't matter. Now that it's different, it's 2x and x, the order matters. So let's switch their spots. Put in the 5 and the 3. Now on the outside, 2x times 3 is 6x. 5 times x is 5x. That adds up to 11x, which is what we wanted. So this is the one we want here. 2x plus 5 times x plus 3. Yep. What's that? Yeah, I know, we're getting thin, but that's okay. We can handle it. Back on now. Try this one in your notes. Any common factors? Looks like there should be, but there's not. Now our first thing is to split up the 4x squared. What do we want to do? Most people go 2x times 2x, right? For those of you sitting there shaking your head, yeah, I know. So now the 12, of course, 1 times 12, 2 times 6, or 3 times 4. Let's try the 3 times 4. So plus 3 plus 4. On the outside, we get 8x. On the inside, we get 6x. That adds up to 14x. Nowhere near the 49 that we want. If I switch the 4x, or the 4 and the 3, does that help? No, because it's 2x and 2x. So we're still going to get the same numbers. Let's try 1 and 12. On the outside, 2 times 12 is 24x. 1 times 2x is 2x. That's 26x. That's closer, but still not 49. Well, we could try all these possibilities with the 2 and 6 and whatever, and none of them are going to work because it's not 2x and 2x that we want. We want 4x and x. Now let's try the 2 and the 6. Why did I put the 6 over here? Because that way it's going to combine with the 4x, and we want a really big number here. So that's going to make the biggest number possible here. 4x times 6 is 24x. 2 times x is 2x. That makes 26x. Still not big enough. So I'm going to get rid of the 2 and the 6. 1 and 12, where do I want the 1? First and the 12 here. Again, so the 4x combines with the 12. 4x and 12 make 48x. 1 and x makes 1x. That does add up to 49x. So sometimes these are just an exercise in exhausting all the possibilities. It's also a great exercise in what they call combinatorics in math. That's combinations of numbers. So you're looking at this, you've got numbers that multiply to make 12, but they have to, when we multiply them in combination, have to add up to 49. So you're taking the 4 and you're splitting up 2 times 2 with all these combinations, and then 4 times 1 with all those combinations. It's a great mental math exercise. Yeah, I know, and you're sitting there like, yeah, I'm still going to run him down in the parking lot later. So this one here, where would I start? Yeah, the first step is always to look for a common factor. Let's do 5x. If I divide that out, I get 2x squared plus 5x plus 3. Now I look to see if this can be split even further. So the 5x would stay. 2x squared will be 2x and x. Now the 3 is going to be 1 and 3. So put in 1 and 3. On the outside, 2x times 3 is 6x. 1 times x is 1x. Adds up to 7x. That's not 5x. Does that mean I'm done? No. It means I got to switch the 3 and the 1. So now on the outside, 2x times 1 is 2x. 3 times x is 3x equals 5x, which is what I want. So 10x to the third plus 25x squared plus 5x factors to be, or plus 15x I should say, factors to be 5x times 2x plus 3 times x plus 1. That is about as ugly as I'm going to get with these. For those of you that are not aware, next Tuesday there are no classes, so there will be no class next Tuesday. However, there is a quiz that is due tomorrow, Friday, at 11:59 p.m. That'll be in my math lab again, of course. And there is homework that is due next Thursday at class time. Also remember, if you haven't done so yet, you do have the test from last week that you can do corrections on and turn back in for up to half of your points back. Okay. Well, the computer lab next door here is open if you want to start on your quiz or work on your homework. Otherwise, we will see you next class.